Now we see the third law of motion. Let us consider two spring balances connected together. Here the two spring balances connected together and we apply a force with the finger. We pull this spring balance. The reading in the spring balance will change because we pull this spring balance. This states that for every action there is an equal and opposite reaction if your force is equal to the readings in the spring balance. The fixed end B of the balance is attached with a rigid support like a wall in the left side. It's a wall, the rigid support. When a force is applied through the free end of the spring balance A, here we apply a force on the right side of the spring balance A. It is observed that both the spring balance show the same readings on their scales. Here both the spring balance shown the same reading because of the third law. It means that the force exerted by the spring balance A on balance B is equal but opposite in direction to the force exerted by the balance B on A because of third law. The force exerted by the spring balance A on balance B is equal but in opposite direction. But the force exerted by the balance B on A, the force which balance A exerted on balance B is called action, and the force of balance B on A is called reaction. Here the spring balance B, here the spring balance A. This is action and this is reaction. Newton's third law of motion states that for every action there is an equal and opposite reaction. It must be remembered that the action and the reaction always act on two different objects. When a gun fired, it exerts forward force on the bullet. The bullet exerts an equal and opposite reaction force on the gun. This results in the recoil of the gun. We explain the third law of motion. When a gun is fired, it exerts forward force on the bullet. If the gun is fired, the force on the bullet is in the forward direction. The bullet exerts an equal and opposite reaction force. The bullet moves forward direction and this is equal and opposite reaction that is exerted by the gun. This results in the recoil of the gun. Here this is the gun, accelerating force on the bullet here in this forward direction. Here recoil force on the direction is the opposite direction. We recoil the gun, the bullet will move in the forward direction. Now we see the another example. A man is jumped from the boat to the table. Here if the man jump to the table, the forwarding force is equal to the backwarding force. The boat moves in the opposite direction. Since the gun has much greater mass than the bullet, the acceleration of the gun is much less than the acceleration of the bullet. The third law can also be illustrated when a sailor jumps forward, the force on the boat moves it backwards. Now before we see here the sailor moves forward and the boat moves backward because of third law. Here we see the animation of third law, Newton's third law. Demonstration of Newton's third law of motion. The Newton's third law of motion states that to every action there is an equal and opposite reaction. Here a rubber balloon without air is attached with a plastic tube. If we blows and the balloon gets air and blows out and release the rubber tube, the balloon moves in the opposite direction to the air blows. Here we see the balloon will move in a direction opposite to the direction in which the air escapes. Here the man releases the finger from the plastic tube, the air escapes from the forward direction, but the balloon escapes to the opposite direction, that is backward direction. This is because of Newton's third law. Here another experiment. A balloon with the air attached with the plastic tube is attached with a small toy car unfolded. Here also the finger removes from the plastic tube, the air escapes to the forward direction and the car moves to the opposite direction, because if the air blows to the forward direction and the car moves to the backward direction because of Newton's third law. The car moves due to the reaction force exerted by the air on the balloon. Here the car moves due to the reaction force exerted by the air blown to the balloon. Therefore the air blown and the car moves in the backward direction. Now see some examples of Newton's third law. The rocket moves to the atmosphere, that is moves to the moon or some other planets because of Newton's third law. Here the energy exerted in the downward direction and the rocket moves in the upward direction. In a jet plane or in a rocket, the products of combustion in the form of smoke, here the form of smoke, the combustion, are ejected outward with a greater speed. These gases under pressure apply a reaction force on the rocket and the jet plane in the opposite direction. These gases under pressure apply a reaction force on the rocket and the jet plane, and it is in the opposite direction, and the rocket moves in the forward direction. The reaction force pushes the jet plane and the rocket forward direction. The reaction force opposite to the reaction force, therefore the rocket and the jet plane moves in the forward direction. Here we see